DEMA stands for Direct Ethanol from Microalgae. It was a €6 million microalgae to biofuel project funded by the European Commission's 7th Framework Programme. It started in December 2012 and concluded in May 2017. The project was composed of a multidisciplinary team of 9 partners from 5 European countries. Under DEMA, 5 research institutes and 4 private companies came together to design, develop and demonstrate a competitive technology for the production of bioethanol from autotrophic cultivation of the cyanobacterium Synechocystis 6803. Synechocystis 6803 is an aquatic photosynthetic bacterium that uses sunlight to grow and reproduce. In the process, carbon dioxide is captured from the atmosphere and oxygen is released via the internal metabolism of the cell. The first objective of DEMA was to genetically modify this cyanobacterium by inserting genes from different organisms so that it gained the ability to produce and release ethanol to the culture medium. Multiple genetic engineering strategies were used to maximize chances of success. The best strains were then studied and screened at lab scale by microfluidics. This technology allowed the sorting and the cultivation of individual cells in their medium within microdroplets. Inside these microscopic drops, it was possible to study the performance of individual cells in order to sort the most productive for further development. Growth conditions of the selected strains were then optimized at the milliliter scale in order to reach the best culturing conditions and to gauge the ethanol production potential. In addition, the toxic effect of the produced ethanol on the cyanobacterium cells was also assessed by physiological studies and flow cytometry. Because the developed strains were genetically engineered, methods to simultaneously generate strains with reduced viability in natural environments were also investigated. Resulting strains were tested at pilot scale for their incapacity for long-term survival in the environment surrounding the pilot scale facility. The second main objective of DEMA was to assess biomass and ethanol productivities. Pilot-scale cultivation allowed the development and optimization of scale-up and production procedures from the milliliter to the hundreds of liters scale. Several photobioreactor engineering and design solutions were tested that culminated in significant improvements on ethanol productivities and its accumulation in the culture medium. Simultaneously, ethanol separation and purification technologies optimization resulted in product-grade ethanol. The data gathered at lab and pilot-scale trials was combined to generate the most favorable scenarios for a complete industrial process from raw materials to the final product. A biorefinery approach was taken and high-value products extracted from the biomass were considered in order to maximize the process viability. The environmental, economic and social impacts of the most promising scenarios were estimated. Furthermore, a complete 20 hectares industrial unit was planned and designed as a model for a business case. The DEMA project brought us closer to a viable microalgae to biofuels production process. It allowed the development of bioethanol production technologies not only at the biological level but also at the engineering level. The DEMA project has made very significant progress in generating ethanol-producing cyanobacterium strains, starting from a strain that did not produce any ethanol. It also demonstrated the cultivation of those strains at pilot scale where ethanol accumulation became routine. The biorefinery business case evidenced the outstanding technology development made in this project and highlighted that with further development, even more impactful results can be achieved in order for bioethanol to become a more significant player in the biofuels marketplace. All DEMA partners would like to thank the European Commission for financing this project. Without it, it would be impossible to develop, scale up and test these microalgae and bioethanol production technologies.